In today's class, I'll be introducing the first principle of differentiation. Now, calculus is divided into two parts. We have the differentiation and integration. But under the differentiation, we'll be introducing first principle. So we have this. If I write something like y equals to x, I need us to note some very key things before we go into first principle. There's something called the dependent variable and the independent variable. So for this, if I write, let's assume, let me not make it x, let's say I have y equals to 2x. Now, if you look at this, if I say let x equals to 1, what would you do? You substitute 1 for x. That is, whatever you see x, you put 1. So this will give me 2. That is, the value of y gives me 2. Don't you think that if I don't have the value of x, I can get y? Do you understand? So that means that y is dependent on x. So which basically makes y the dependent variable and x the independent variable. So that means if I don't have the value for x, I can't get y. That's what it means. So we would have that if we're given y equals to x, we are asked to differentiate y equals to 2x with first principle. Now, how do we go about this? We have y equals to 2x. First principle is a series of steps that you must follow to the letter. So it's a bit long, but you must follow the steps. It's not difficult. So if I have y equals to 2x, for the first step, if I have y the dependent variable and x the independent variable, I would add the value y for the dependent variable plus the derivative of y. Then I'll do the same thing to x. I'll have x plus change in x. So what that basically means is that instead of me writing y here, I would have y plus change in y. Then whenever I see x, I'm putting what? X plus change in x. This basically applies in all type of questions. So whenever you see x, just put x plus change in x. Whenever you see y, y plus change in x. And be aware that it's not only every time that you have y and x. You can have a and b. You can have c and d. Basically any variable. So if you are asked to differentiate, you just differentiate with respect from the dependent variable to the independent. What I mean by that is you are differentiating with respect to x. That's dy dx. So if I have this, I'm going to have y plus change in y equals to 2x plus 2 change in x. Now step number 2. Step number 2 is that I'll deduct y from this side and deduct the value here from this. So what's the value that I have here? Y. I'll deduct it from this end. I'll deduct the value that I have from this end. So what I have on this end is minus 2x. Deduct x from here. So if I have y plus change in y, I'm deducting y from this end. So what I would have here is y minus y. I would have 2x minus 2x. It's compulsory that at least something goes out. So I have change in y will give me 2 change in x. Now remember that we are differentiating with respect to x. So we have to divide all through by changing x for our third step. You are dividing all through by changing x, dividing all through by changing x. So what you will have is change in x cancel change in x. Then you have change in y over change in x is equals to 2. This is not our final answer, right? Because you need to find dy dx, not change in y over change in x. So what you do to find dy dx is you limit the x to 0. You have change in y over change in x equals to, that means limiting the x to 0 basically means if change in x still appears in your solution, you put 0 where it is. But if we check our solution, change in x is no longer there. So I'll just put 2 as the final answer. So this basically means that we have dy dx is equals to 2. So when you limit the x to 0, this change in y over change in x automatically becomes dy over dx. So we have y equals to 1 over x. We want to use first principle to differentiate. So what we would have is y is equals to 1 over x. Now, If you remember the first step that we treated, it's still the same process, regardless of the question. We have y equals to 1 over x. So wherever I see y, I'm writing y plus change in y. Then wherever I see x, I'm writing x plus change in x. Is that okay? Remember step number two. Step number two says that I will deduct the value that I have here from this end, deduct the value that I have here from this end. So what I would have is y plus change in y minus y equals to 1 over x plus change in x. What's the value that I have here? I have 1 over x. I'm deducting it. So it's the same process. This cancels this. Is that okay? Then I have change in y is equals. Then I need to subtract this. So I need to know the LCM of these two things. Of course, I can't find the LCM. The only thing I can do is multiply them together. So the denominator or the LCM will be x into x plus change in x. I multiplied them together. So what we are going to have is, if we remove change in x from this particular expression that we have here, what do we have left? Then we have x. That is, if I cut out change x plus change in x, cancel x plus change in x, what would I have left? X. So x times 1 will give me what? X minus, if I remove x from change this particular expression that I have here, what would I have here? I would have this left. So this times this will be what? X plus change in x. Hope you notice that I introduced a bracket. Now I did that because if I remove x here, I'm going to have these two things, but there are two terms. So I cannot just use a minus sign without introducing a bracket. The minus sign must multiply what is inside all through. So I introduced the bracket to demarcate that, oh, I will need to open the bracket with a minus sign. So we are done with this part. We have change in y will give us, if we open the bracket, we have x minus change in x, because minus x minus times plus give us minus all over x into x plus change in x. So obviously x cancels x, we have change in y equals to minus change in x over x plus change in x. Now step number 3, if you remember step number 3, divide both sides by change in x. That's step number 3. So we divide both sides by change in x. Now if I'm dividing here by change in x, you agree with me that if I change division side to multiplication, what would I have? I'm going to have a reciprocal. That will become what? 1 over change in y. So 1 over change in x. So what I would have here is times 1 over change in x. So change in x cancels change in x. I'm going to have what? Change in y over change in x will give me, what I'll have here is minus 1. Minus 1 times 1 is what? Minus 1 over x into x plus change in x. So we have this. Now after this, the last step is to limit the x to 0. We are limiting the x to 0 so that we can finalize our answer. So what we are going to have is limit of the change in x to 0 will give me the y over the x. That is, whenever I see change in x, I'm putting 0. So minus 1 over x into x. Now what I would have here is, I'm writing 0 there. So we are going to have that the final answer of this, because if I limit change in x to 0, I'm going to have the y over the x is equals to minus 1 over x into x plus 0 is x. Then this gives us minus 1 over x squared, right? So the y over the x will give us, so if I remove this reciprocal, this 1 over, I can write it as a negative index. But this minus is standing on the side. So if I remove this 1 over, it will be a negative sign in the power. That will be x raised to the power of minus 2. I can leave this as my final answer, or this, whichever one you choose to write. Is that you leave it as this, or you leave it as this as your final answer. We have this as our number 3. So we are still following the same process. And what's the first process? Wherever I see y, I put y plus the y. Wherever I see x, I put x plus change in x, then y plus change in y. So we do that quickly. Y plus change in y will give us 4 into x plus change in x square minus 3 into x plus change in x plus 9. So I need to open this bracket on this end. I need to open this bracket. So I would have y plus change in y will give me 4 into, because this is square, I would have x plus change in x plus change in x, right? They are multiplying. Let me open this side. I'll have minus 3x minus 3 change in x, because minus 3 times plus change in x, I'll have minus 3 change in x, then plus 9. So on this end, we are still having y plus change in y. Now we need to expand this somewhere. X plus change in x, x plus change in x. So if I do x times x will give me x squared. X times change in x, look at it. I'll have x change in x. I know some of us might be thinking that is change in x squared, but that's not true. What I have is x times change in x. So this is different from this. They are two different things. I can only have change in x squared when I'm doing change in x times change in x. I will have change in x squared. So what we have here is x times change in x. Then the next one is what? Change in x times x will still give me x change in x. Then the last one is change in x times change in x. That's what I'm talking about. I'll have what's change in x squared. So this plus this, they look alike because they have the same variable. I would have x squared plus 2x change in x. Then the last term that we have is what's change in x squared. So the expansion to this thing is what I have down here. So I'll replace this with this expansion 4 into x squared plus 2x change in x plus change in x squared minus 3x minus 3 change in x plus 9. So we need to open this bracket with 4. We have y change in y, then 4x squared, 4 is multiplying all through, plus 8x change in x. 4 times this will give me what? Plus 4 change in x squared. Then I have minus 3x minus 3 change in x plus 9. So step number 2 now. You notice there's only one step we have done, and that's x plus change in x, y plus change in y. Just follow through the process. So step number 2 is deduct this value from this end, deduct everything here from this end. That's what we want to do. So we would have y plus change in y minus y. Remember, this will cancel this. Y minus y will give us what? 0. So if you've been following through, everything here still results to change in y. So we did not to just waste our time doing that. So here will result to change in y. Then on this end, let's just repeat what we have here. 4x squared plus 8x change in x plus 4 change in x squared minus 3x minus 3 change in x plus 9 minus. So I am deducting everything here. That's 4x squared minus 3x plus 9. I am deducting from here. So I'm introducing a bracket because there are several terms inside. So the minus has to open the bracket all through. So we would have change in y will give us 4x squared plus x change in 8x change in x plus 4 change in x squared minus 3x minus 3 change in x plus 9. If I open this bracket, I'll have minus 4x squared minus times minus give me what? Plus 3x minus times plus give me minus 9. So if I look at what are those things that look alike, look at 4x squared, I have minus 4x squared here, so they can cut. So whether they are far apart or they are close, I can still subtract them. 4x squared minus 4x squared will give me 0, plus 3x minus 3x will give me 0, minus 9 plus 9 will also give me 0. So I'll write out what I have left. So what we have left is change in y will give us 8x change in x plus 4 change in x squared minus 3 change in x. So this is what we have left. I haven't subtracted. So second to the last step is divide all through by change in x. So we divide all through by change in x, divide change in x, change in x. So we have change in y over change in x will give us, this cancels this. We have 8x plus, I'm removing 1 out of this, is remaining 1. So what do I have left? 4 change in x minus, this cancels this. What do we have left? 3. So the last step, that is limiting the x to 0, limiting change in x to 0 of change in y over change in x. That means wherever I see change in x, I'm putting what? 0. 4 into 0 minus 3. Then the final answer, which is dy over dx, our final answer is what? 8x minus 3. 8x minus 3 is our final answer to the derivative question.